So, in today's session, I'll be going to discuss another data science project. The mainly is propensity to subscribe a term deposit. Propensity is a banking term, so it's basically referred to known as likelihood, or maybe what are the chances that particular customer will subscribe to a particular product of the bank, or maybe get a loan, or maybe credit card, or maybe any deposit is basically mainly represented as a like any policies that bank have. For example, for the investment, mainly in the investment terminology, like if you would like to invest FD or whatever it is, bank to bank, the particular term usually changes. So this is like the bank marketing data set, where bank have some like employees to them, like call center guys or some, like you can consider like this, and they usually will give you the call like, are you interested for a loan, or maybe are you interested for a credit card, or maybe are you interested to invest, this is like our new policy, are you interested to invest in our new policy, and these are the like benefits of this particular policy. Lots of like this kind of calls, like nowadays people usually get, and they just try to understand what are the chances the particular person will subscribe, or maybe take a advantage of whatever the particular customer call center guy is trying to say over here. So that's what we are trying to see. So this is basically again a classification problem. So where we will just try to see if the particular person will subscribe to a term deposit or will not subscribe to a term deposit. So it's a binary classification problem. So let's just directly jump on to the Jupyter notebook. So I already have given some insights over here, like banking terminology, what is propensity model, or maybe what actually bank would like to earn out of this particular problem. So initially in the bank, the problem statement usually start earlier. They probably have a lot of customers who intend to buy multiple products of the bank, multiple product as in different investment, but gradually those are the investment breakdowns and goes down and down. So they just wanted to understand the reason why existing car clients, or maybe probably new clients, are not trying to buy the new product. So they probably have to do the like more marketing, and based on that particular marketings, they are just trying to achieve a customers, or maybe leads, you can say in another word, who can subscribe or buy their products, and they basically furthermore can increase their revenue. So as you know, whenever we have the funds, or maybe some amount, we can do the like some investments, or maybe do the share market, whatever it is. So bank can make advantage of those funds, or maybe can give the loan to the different persons, and out of that they can generate the revenue. So that's the bank problem. So again, that particular problem had converted into the data science problem statement. It's like more of like very straightforward, that just wanted to see client will subscribe to a term deposit or not based on some input variables. That is what we have received or achieved from marketing campaign. So whatever the questions, like somebody, probably subject matter expert, will curate a questionnaire, and they will directly give to the marketing campaign, and they basically marketing campaign will start asking some questions to a particular person or clients, and based on those particular questions, basically different banks usually build a model. And once they find out like these are the like basically clusters that are more inclined or intend to buy a product, so they usually start again doing vast variety of marketing. They will start calling those, or sending the email to only those who are like eligible leads, instead of sending to all their data set like millions of customers. There is no point. Whoever is actually in a positive direction, they can directly send all the offers or start calling to the those people only. So that's what the data set looks like. So it's from, again, from the Portuguese Banking Institute. It's open source data set that we have considered today, and data set is again openly available on a Kaggle, where you can play multiple things. That the particular data set has 32,000 rows, 21 like if basically the features, including the target feature as well as your independent features. So total 21 features we have. So some of them might be important one, some of them might be not important one, you can see. So the today's main goal is not only focus on basically doing the data cleaning, data exploratory data analysis, or maybe something like that. We just wanted to move or maybe think out of box. So far in our previous projects, we used to do our lot of work on a Jupyter notebook and just try to understand the data and the various techniques as deep as we can. So this is not the current session is current. I still gonna cover few of the techniques that you already have learned in previous projects, but the main purpose is just try to understand the .py files and do the automated work in order to train or predict or maybe whatever the task you are going to perform. Not always you have to use the Jupyter notebook. So let's go much detail. So these are like a library for the data loading, data manipulation. Matplotlib, Seaborn are specifically designed for a data basically visualization, and these are the like sklearn different branches. So this is the sklearn library, this is the branch, and this is the actual class that we are going to use out of that particular branch you can consider. So few of them are for the data preparation, few of them for the data pre-processing, few of them for the model building, and few of them for the model evaluation. So dataset, it's just train.csv. It's like data name that we do have in our basically this local disk store in the same directory where this propensity model experiment Jupyter notebook is there. So and this particular dataset is basically separated by this semicolon. So you might have to see, like if we remove this semicolon, you can see that like how the data set will look like. So you probably will not able to load it in proper format. So you can see that age, semicolon, job, and everything is goes over here. So with the help of that also you can understand how the data set columns are separated from each other. So I just got to understand with the help of simple default data loading. Then I observed that data set is separated with the help of the semicolon. So you can just load that, and this will properly get divided over here. So the sample 10 observation that we are printing over here, you can see these 21 observation: age, job, marital status, education, default balance, housing loan, contact day, month, duration, camping, previous days, and pay outcome. Why? To get the like more clear picture what this data set means, so you can also see that this is the like Kaggle data set as I mentioned earlier. So over here also you can get like much clearer idea about the like each and every column, what this particular column means, and all those stuff, education, default, or maybe their distribution and everything. So this is also information is available over here, so you can get from that over there as well. So I'll not go much detail into the data explanation part. So data understanding and exploration, first thing that we always perform is data describe function usually works on your numerical variable, whichever the variables are the numerical one, try to calculate the mean standard deviation. With the help of that you can get an like overview about your data set, how the data distribution looks like, what are the like statistical terminology actually helping you to understand the data set. Then we can also see the data distribution for your basically the target feature or maybe output variable. So yes means like who are actually subscribed for a particular term deposit that bank is providing, or maybe the banking product you can say. And the no, like basically these are the like people they have not subscribed to the banking marketing campaign. So data set is pretty imbalanced, you can see over here. So you can perform the imbalance technique to balance it. And as I mentioned earlier, that we are not actually gonna discuss more into what exactly the each and every line of our code. For that, we have already recorded the like some videos and already posted on a YouTube channel, so you can refer to them in order to understand each and every line of code. So instead of explaining each and every line of code, today what exactly gonna do, I'm gonna automate the process. That's what the entire session calls as a end-to-end data science project. So I'm but directly jumping into a automated process that might be tough for you to understand. So still I'm going like in not in detailed way, but I'll try to cover as much as I can. That's what the session is. Okay, so and additionally I'll add the like few comments over here. We do have like commented data science projects. I guess a lot of projects are already commented over here. So each and every line you can get like come back to this particular session, sorry, projects, and you can see the explanation. For example, this loan repayment prediction is like a very detailed one and commented one project. So you can see multiple projects are already listed over here, and most of them are commented one, but I'll still comment, will provide the like as much as comments I can in order to explain the project.
Okay.
Okay, then um, understanding the data set with a business perspective. So business perspective is like plays very major role in your interviews as well. Like if you play with your data science projects technically, that's not enough. For example, you have built a credit card fraud detection model, and probably they will start asking the question, what's the difference between credit card, basically we have like credit score, which varies from 0 to 800. So that's what we call it as credit score in specifically in India. So what kind of credit score other banks use, for example Portuguese. So if you have mentioned that this particular data is from Portuguese, so you should know what kind of criteria they follow, how much loan they provide, interest rate, and all those basic stuff for this particular country wise, because you are considering the country wise data, and that's what you are basically adding in your resume. So you must be sure about all those things. Not every time whatever the terminology is being used in a Indian banking will definitely gonna be used in a Philippines. For example, currently I'm working in Union Bank Philippines. There is lot of changes that is being happening in the Philippines, for example geolocation or whatever it is, and their way of understanding and their business perspective is a completely different than how Indian banks usually handle those situations. That's the reason every bank have a huge number of employees specifically working on a business side or maybe on a behavior side, so they can give the like proper inputs to the data science team. But that is something will be happen when you actually enter in a particular bank or maybe in a company to start working on. But at least basic understanding you should know with respect to the business perspective. So this particular data set is a term deposit, like particular person or client will subscribe to a brand product or no. So we probably have like some sense what kind of variables can play major role over here. That's not the always the situation that whatever we thought will always play, but at least we have to come up with some solution. For example, age group. So we know that like typically people who in start investing at their age probably 22, 23, 23 or maybe around 25, because that's when they start earning. That's not the situation in US, because US I'm sorry, US gets like employment much earlier than the Indian people. Indian people get settled around 25, whereas US people get settled around 18. So obviously age group change from the country to country. So for this particular data set, Portuguese people, I observed that people are usually get settled around 20 to 60, and that's where the like target people we can target, not below 20 or not about 60, something like that. Also balance is plays very crucial role. If balance is high, obviously people will do the investment. Otherwise, if their balance or salary is below some level, definitely they are not going to do the like some investment. There is like also another variables that's are part of this particular Portuguese data is a housing loan, personal loan. So like we need to think like if the personal loan and housing loan usually help in order to see if the person is gonna do the investment. Probably it's not always true. The reason is whoever has a loan, they probably doesn't have money to do the investment. So that's also an situation. Or maybe person take a loan for a personal loan for a investment purpose only, because they know that for the loan only 10% like interest is there, but investment they probably will get 20%, 30% if they are like good skilled in a investment and share market, whatever it is. So just try we can as a data scientist, you can do that with the help of data visualization. So you already have learned about the tabulate, some of you are already expert in a Power BI, so you can perform the EDA or data visualization in a business perspective in your visualization tools, or maybe you can do it in your Jupyter notebook. So for the Jupyter notebook, you simply have to use the matplotlib or Seaborn library to play with that in order to see. For example, this is one of the example where I and one more thing, when you actually try to understand the your data set, it's not the always a case that you always have to look for only one variable. So most of the cases, not only in a banking but probably in healthcare as well, combination of variable, a combination of different variable plays very crucial role. For example, age balance as well as the loan, or maybe the age and person's status, married, unmarried, or something like that. So combination of two roles can play a major role for a better explanation what will happen for this kind of cohort or group. So I consider the three variables over here instead of focusing on one variable for a data visualization. You might have seen earlier cases like we just perform the data visualization on a particular single variable, or maybe max two variable. You can consider three, four, five, whichever you think this combination is like more of inclined towards taking the term deposit from a banks. So here you can see that like age group from like around 22 to around 65 or something. Balance, you can see the balance people are like 0 to like 400, sorry, 40,000 USD or something. I'm not sure about the currency that the data have provided in a Portuguese data. It might be USD or something like that. Need to confirm that part. So that's the like distribution we have got over here. So we can see that most individuals do not have a loan on their homes, but most individuals who will have a loan on their homes are consider concentrated between the age 25 to 60. Like what exactly it mentioned over here is like basically the housing loan that we have is a uh, yes and no. So no are the like most people who doesn't have the housing loan, and yes is the like basically the people who has a housing loan. So that's how the distribution over here. So yes and no, instead of focusing on whoever has a housing loan, they basically are a part of 25 to 60 age group. So that's what the conclusion says over here. Then similarly, we can see the visualization for a personal loan. One we have seen over here for a housing loan, one we can see over here as personal loan. So most of the Portuguese data set that we are considered over here for a propensity model, they basically doesn't have the personal loan. So whoever has, they are again between the age 20 to 60. So similar kind of conclusions you can make. So basic conclusions I try to draw over here is age ranges between 0 to 22 to 70 or 60 years old are like more inclined population towards subscribing for a banking products. Personal loan is not that much of effective. Housing loan is bit of helping our model to understand the person will subscribe to a loan or no, but basically personal loan is not like helping at all. So this kind of visualization you can perform on this particular data set based on whatever you think might will play a role over here. For example, marital status or a job or education, or maybe their contact, or maybe the duration, camping, whatever the variables you think are basically plays major role. So in order to understand, or in order to think of this in a banking's perspective, you definitely need to read some papers or maybe some banking articles in order to understand the banking terminology. It's not something is a one day job, definitely. So but at least basic idea you should have in each and every domain in order to explain your project to your recruiter team or whatever it is. So just two things I perform over here to give the better idea how exactly you can think of your data set in a business perspective, and why this is important for you to think of this in a in a business perspective, maybe for an interview, maybe for your job role that you are going to play when you got selected in a particular company. All right. So once the standardization and basic data pre-processing is done, so we usually move our data sets, training and splitting, like split the data set into the training and testing, and then perform the model building. So as I mentioned earlier, so you can add the like multiple pre-processing and data cleaning techniques over here in order to play with your data set, but that's the like most important and the must do things that you should do when you get your data set and you have to build your data set. Once that is done, so basically every time when you work on your projects, it's not the always situation that you have a less data sets. Like when you actually enter in a company and when you start building your projects, like most of the times, I'm not saying the most of the, it's always a case that you usually have a very huge data set with you, probably 1 lakh observation to millions of observations. So in that situation, every time you won't be able to perform all the things that you have going to perform on your data set and then do the model training every day. So better automated process is, you should divide your task in a three different way. One is a prepare a data set, second is train a data set, and third is the model training or maybe the model evaluation or maybe testing, you can say. So once your dataset is clean and readily available for a future model training task, so in at that time you should export that particular dataset in a CSV format. So we already have discussed how exactly we can export our dataset in a CSV format. So basically here with the help of standardization features, we have got the features dataset only here, because in order to apply a standardization, we basically have to remove our categorical variable from over here. That's what we did over here. We basically have removed it and just perform the standardization on on basically our input variables. Then again, whatever the standardization data set I have got over here, then I have added again my target variable over here. So you can see that just the data pd concat is like one of the pandas function, you can use that. Axis is equal to 1 is basically you just wanted to concat your data set with a column wise, not like this particular variable is down there or something. Just all your feature variables over here, and you wanted to add your target variable over here. So that's why I said like column wise you wanted to do the addition of two data sets. That's the reason I use this pd concat over here. So and then you can just simply export your data set in a CSV format. So that particular set will be exported over here. You can see that final version CSV. So whenever going further, like for example tomorrow or day after tomorrow, or you spend probably 8 days working on cleaning your data set and all those stuffs. So at the end you can export it, and now you probably wanted to spend another 7 days, 4 days, 5 days in order to see which model performs very well. So that time you can always use this final version of your CSV, which has your clean and pre-processed dataset. And with the help of only this particular dataset, you can proceed further and do your training. Firstly, you have to build your baseline model, just any simple model, or maybe combination of different models. For example, logistic regression, SVM, random forest, decision tree, neo base, knn. So 4 5 6 models you have trained, and you came to know that for example random forest basically giving you the better result. So then for a particular random forest itself, you will start doing feature selection, like trying to understand not all the features are important. Sometimes probably only 6 features or top 10 features are important, but rest of the features are not important. So for that we perform the feature importance techniques, or maybe imbalance data set technique, or maybe hyperparameter tuning, in order to increase your model accuracy and model stability. So model accuracy increases is one task, model stability is another task. So that's two things you need to perform. So I already see check which model performs very well. So over here I just added the random forest, because like to see what's the accuracy you are getting with different model is a straightforward job. You just have to replace this with your like class that you have. For example, logistic regression, Bayesian, KNN, whatever it is, and then you can just simply do the calculation which model is performed well. So logistic regression, I guess I got accuracy around 75 or something. Similarly, but random forest gave me the better accuracy. So that's the reason for a baseline model I chose a random forest, and we are going to now play with the random forest model in order to increase the accuracy, or maybe you can say in order to stabilize your model. So again, you can add the steps over here. You can also play with this particular data set and try the different model. So that is not a rocket science. Okay, so once you get this, for example, 89.62% accuracy is something with all the input variables. So these are the like input variables. So then again, I wanted to move to the another thing that usually performs once you choose your baseline model. So over here, I chose a random forest as a my baseline model out of 10 model, for example. So then I wanted to perform the feature importance for this random forest model to see if I chose top 10 features, how much accuracy I am getting out of it. Like, is my accuracy is improving or my accuracy is not improving? And there are like again multiple techniques to perform the feature importance, just like other techniques. For example, missing value, you can replace the value missing value with a mode, with a median, or maybe with a predictive model. So similarly, for a feature importance, you have AIC BIC criteria, or maybe you can perform decision tree, top 10 features, random forest top 10 features, or maybe there are like multiple techniques, and not it's not the always situation that random forest top 10 features will work in in your situation, or maybe on your data sets. There might be the AIC criteria is giving you the better results than the random forest, or maybe there is no requirement of feature importance at all. So feature importance means selecting top features from rest of the features. So over here we basically have around 18 features. So instead of considering all 18 features, top 10 features you can consider, and you can play with only the top 10 features. So that's what the feature importance means. So you can see that in our, this is our basically the duration for a particular term plays major role, then the balance, then the age, job, previous dates, outcome. So like this, like you can see that whichever the variable has like highest value or peak point, this particular variable has a highest importance in your model, or maybe you can say this particular variable plays uh, crucial role in your data set. So let's see, like you can extract those particular features and can store in a list format. Then you can prepare again your data set. So earlier X that we consider before for a training is a final data set. Final data set means this one, which has all the independent variable. So in the X top, you can see that you basically have only the final data set with the important feature. You can print that over here if required in order to see. So you can see that like only 10 features are reflected over here, and you can build your model on this 10 feature itself only. So you can see that like again I splitted a data set into the training and testing, uh, sorry, train X, train Y, train Y, whatever it is, like four features. And over here, instead of X, I consider the X top, which has only 10 like top 10 features. And then I perform accuracy over here, but looks like my accuracy is not improved, but it's basically got decreased. So that's the reason I have s- added to my observation over here is a feature selection can differ from problem to problem. In those cases, feel free to try other methods like PCA, principal component analysis, select BERT, or maybe select percentile, TSNE, or maybe AICBIC. Like there are like 5 to 6 methods for a feature selection. Feel free to you can try those methods and see if any of the method is helping. If not, then you can keep all the variables that you have in your basically the training data set and can start directly playing with that. So in our situation, I just ran random forest feature selector, but that seems like it is not working, or basically it's not helping me to improve my accuracy. So as long as it is not helping me to improve my accuracy, I should remove that particular part from my data science experiment. So you can see that, like, file name itself says the propensity model experiment. So we basically are just performing the different experiments over here in order to go with the like single method that is basically helping in your situation. So this kind of experiments you can perform on your data set to get the like better results. One, like, as I mentioned, this is not working at all, so I'll just again go with my existing data set, because top 10 feature is not helping. So I'll just go with the like the whatever feature is over there. For example, I have like, you can see that how many features that you have over here for a final data set. So basically 15. So 14 are like basically input variables. So I'll just go with the 14 variables that I have. And for that, I'll just again, next step is hyperparameter tuning. So we already have discussed multiple times what hyperparameter tuning is does, but I'll brief this in short. The hyperparameter tuning is basically required when you actually wanted to choose a best parameters. So every model has a parameter uh, that exists. For example, for the random forest, which method you would like to, go, or with the criteria like Gini index, entropy, or maybe information gain, then maximum date, this kind of features. Basically you can choose. For a SVM, you have like parameters like kernel, then C, gamma. Those are the like parameters that you have in your SVM model. For example, in logistic regression, you have the kernel, like which kernel specifically that you would like to go with. So every, like, when you choose over here, you can see that, like, you can go over here and press your shift tab button, and then you can see over here, like, these are the like default features. For example, criteria Gini is a default when you have not given any criteria over here. Maximum date is again none, so it's basically your numerical values. And then these are like not the important, like, then maximum features is just sqrt, then cot, whichever that you would like to use. And these are the like default features, and default feature sometimes doesn't work. You basically have to choose a particular features. For example, Gini index, the loss and the log loss and entropy are the criteria. So which criteria, with the help of which criteria you would like to split your tree, because every criteria has a different logic. So, or maybe every feature has a different logic. So we basically wanted to choose a best parameter out of whatever the default or maybe the given. So for that, we perform the hyperparameter tuning. Hyperparameter tuning code is again pretty simple. You just have to create the parameter grid, and then you have to use a grid search algorithm. So that is again a part of your sklearn library. Over there, you can place your model that you have defined over here, and then the parameter grid. So once you basically do this grid search algorithm, on top of it different parameter, it will just do the multiple iterations and will give you the best result, which basically the combination of parameters are actually performing well. So in our situation, Gini criteria for a decision tree splitting, or with random forest algorithm splitting, and the maximum date is 8. So these are the like two parameters are working very well. So instead of just not giving any parameter, or maybe I would say the default parameter. So default one is a basically the Gini, and maximum date is basically default is none, means they usually consider the one. So instead of one, maximum depth 8 is performing very well. So you can pass those particular features whichever you have got from hyperparameter tuning, you can place over here, and then again you can calculate your accuracy or maybe the performance matrices. So my accuracy have increased around 1%. You can say earlier it was around um, 89.62 something, and over here you have got like 89.81. So like minor changes is there, but still this is like this plays very crucial role when you are presenting this to your business team or maybe to your manager. So point percent or maybe milli percent accuracy is also the quite important. That's how we usually try to, like, basically generally the situation is when you got accuracy around 85%, your manager or your business team always push you to achieve accuracy more than 90%, sometimes more than 95%. So in order to achieve accuracy or maybe improve, this is like what you have got with the help of these basic steps that I performed so far. But if you wanted to reach more than 90% or maybe around 95, then you can add the multiple data pre-processing techniques. You can implement different feature important techniques, or maybe you can uh, do like other steps that is required again in a data pre-processing, so that basically will help you. Or maybe a random forest itself is not performing probably well with the help of only the baseline model, so you can do the hyperparameter tuning again on a logistic regression or maybe any other different model. For example, XGBoost is like also the one of the top model that we have very huge data set with us. So XGBoost can also will play the major role if you plan to build a XGBoost model, because whenever you have a very huge data set, more than 30,000 or 40,000 observations, so in that situation mainly random forest or XGBoost performs very well. But compared to random forest and XGBoost have like very promising results. So you can replace a random forest with XGBoost and can see how much accuracy you are getting. Like, is there any increment in your accuracy or no? So that's what you can do as a your experiment. But this is like, as I mentioned again, it's like you are performing in a Jupyter notebook, but you have to choose, like for example, for a feature importance, you have tried five different methods and you just decided to go with the one. So that is something you have to cut, or maybe you have to extract that information or with the code of snippet out of that particular boundary and box, and you must have to store that information somewhere else. So that's what automation job do. So it just automation means it's nothing but like creating your .py files and like storing the information, which is actually pretty much important. For example, data cleaning data set we already have discussed in Jupyter notebook. So you can see that for the cleaning data set I have performed replacing the unknown category with actual, like basically the mode of that particular category. Then missing value duplicates I have not performed over here, because that was only the experiment and I didn't have any missing values or duplicates, so I should not add over here because I was not doing anything. First you have to check, or maybe you have to detect, and then once you detect something in wrong in your data set, then you have to correct it. But while detecting itself, you, if you have not found anything, then you basically have there is no requirement for you to do any such a task in your automated process. So similarly, missing value, I was not having any missing value, so I have not added anything over here. Just whatever the basically operations that needs to be performed on a original data set, that's the only thing I have added over here. So DF, you can consider this as your original data set. So in your original dataset, I basically removing unnecessary or noise from my dataset feature wise. These three features, categorical features. Then I'm also removing unnecessary columns from my dataset. Then label encoding that needs to be performed before training the model. So label encoding code is over there. Then the standardization of the features is again important. Then you have to like basically export your data set. So this is like the when you create your user defined function, and again whatever the functions that you have added, code snippet you have added over here, required libraries also you need to add over here. So you can see that basically. So let's test this particular code as a demo somewhere over here, not here. So you can see that, like, again, so this is like the .py file that I have created. So .py, creating .py file is a straightforward in a Jupyter notebook. You like when you launch a Jupyter notebook, you just simply click over here ipy kernel. But if you want to create a .py file, you can go over here and create, for example, temporary dot py, and you can okay, so I'll just leave. So something like that, files you can create. So I created similarly data processing, because I wanted to do the data pre-processing. So data processing means I just wanted to load original data set. I wanted to perform certain operations on my original data set, and then I wanted to export clean data set again in my local disk. Local disk means this local folder. So final underscore version csv, something like that. I just wanted to export once the data cleaning is done. So once I create this .py file, you can just go in a demo Jupyter Notebook or maybe any terminal. So over here you can again use your .file as a library extension. For example, from a data processing means this library, sorry, this Python file name. So and in my data processing Python file, I have one user defined function name as a clean data set. So that's how I am loading that functionality from my Jupyter, like in my Jupyter notebook, from data processing import clean data set, because clean data set is a function that I am going to use, which has an input original data set and which has an output clean data set. You can see that, like we already have discussed multiple times about the user defined functions. If you are not if you still have some doubts about how to create the user defined functions and all, I'll share one of the link that we have posted one video on our YouTube channel where we have explained about the all the object oriented programming and user defined functions, and this how we can write our .py files and how we can load that .py files in our Jupyter notebook. So I'll not go much detail over there. Then similarly, I have another .py file which is specifically designed for a training model. So for a training, what we need, our final data set. Obviously, final data set means our clean data set. So once we add our clean data set, then we basically create our x and y. Once we have our x and y, x means your features, independent features, y means your target feature, or maybe you can say this as your input features, and this you can say that your output feature. So that's, and these two features we provide into the train test split, and we split dataset into the training testing, these four parts. Once we achieve like get these four parts, we pass these four parts again to the basically the model that we have. So model part is again simply from a hyperparameter tuning. We already have got to know that Gini index, sorry, criteria for a Gini performs very well rather than log logs or maybe like information gain, and maximum depth is one, that is like plays very crucial role in order to get the better performance or maybe the better model evaluation matrices. And random forest is something that you can assume that over here you have tried basically 4 different models, and out of that random forest is performing well. So that's the only reason you have added this particular random forest in your final sheet or maybe in your final code. So you don't always have to train all the models in a same file. So that's the like major role. And then we have added the evaluation matrices over here. The print function obviously you can add. Then to save a model, so there are like two open source libraries. One is the pickle and another one is a joblib. So you basically have to like basically give the name, like what name you would like to give your model when you export that model in your disk or maybe in your local directory or maybe in your laptop machine, whatever it is. So pickle is like just one line code. Pickle dump means basically it will dump whatever you have. RFC model means the model which you have created over here. Then open file and write. So write basically when we would like to write something, we basically use the wb. When we would like to read something with the help of pickle library, we use rb. So that's like simple one line code in order to dump your models. So and then I'm just returning the my model which I have trained over here and which I have basically fitted over here. So RB rfc underscore model dot fit. This basically command train your data set, that x train and y train together, and build the model, and can store the whatever the information or maybe the values that you have received in this rfc model itself. So you can see that once I run this particular code, you will get this propensity underscore model dot pickle. So that's what you have done over here. So you can again go back to over here and see, like from train, this is my train dot py. So from a train, I would like to import a function train underscore model. So you can see that from a train, I have imported a train underscore model. Pandas.pd like basically is required again just to load the data set. So for your data pre-processing, the input for your data pre-processing means data clean is basically nothing but the your original data set. So your original data set that we have discussed is a train.csv. So that original data set I'll just load in Python. You can see that so I have loaded the data set, and that original data set I am passing to this particular user defined function. So once I run this particular shell, you can see that you are getting the final version. So you can see that like final version seconds now. It just got dump at, when I run this particular cell. So this will clean your data set, and you will get the like clean data set dump out of this particular function. Then I just wanted to load this particular clean data set that I have exported right now. And then that particular clean function you can basically load, and then you can call your train underscore model user defined function that you have created in your train. This particular function will create your training testing files, then load the model, and then basically dump the model out of that particular box. So you can see that. And also we already have added some print functions for your evaluation matrices. So you will get the output for the evaluation matrices as well, like confusion matrix, classification report, accuracy, and propensity underscore model dot pickle file dump in the directory. So that is also print function that I have added. You can see that propensity model underscore dot pickles dump just second ago. Means like when I ran the cell, it got dumped. Then for the prediction, similarly, you just have to load your propensity model using again pickle file. You can see that over here, load pickle file, and then the model that you can load from over here with the help of pickle load. So for a pickle dump, like in order to dump the model, you use the pickle dot dump. In order to load the model, you use pickle dot load. And this is like common the file name, and then RB means read, WB means write. So these are the like two things that you have to use inside that. Once you do that, this is the model that you provide again for the prediction. So similarly, that we perform wherever we would like to do the model evaluation. So you can see that like RFC is a model name that I have built over here. Then that particular model, in order to do the model evaluation, I am again pressing that particular model over here. You can see that RFC dot predict, then X test. Basically, data set is being used for the prediction. So same thing I'm doing over here. Only thing is that just change the model name as a variable name while loading this particular model, and that particular variable name I have used over here uh, as a model name, and then I'm predicting it again on a X test, and then these are the like evaluation matrices. So this is like again simple code of this splitting, split the text and all, and these are the like important things that required. For example, pickle for the pickle load, then the accuracy. So these are like library basically that needs to be perform all these operations. So once we run this, you can see that like you are getting the like same accuracy with the same model. So like again at the end you are dumping the same model. So once you load the same model, obviously you will get the same accuracy. So this is required. The reason is when you have millions of record with you, and if you start training, so that in your laptop, if you start a training of a particular model, that probably will take 1 day, 2 day, 3 day. So after 3 day, once you get your model train, so that time you basically wanted to export that particular model out of this Jupyter notebook, so that whenever you have a time or something like that, you can directly start and directly jump on the prediction part. You don't have to train it multiple times. So that's the reason we usually dump our model to automate the process, or maybe to automate our job. So this is like, again, so if you want, like, I'll just create this as a user defined function.